Hi guys, we're starting chapter 7 today, so this is 7.1. And it's kind of a long PowerPoint, but I'll try to get through it as quickly as I can. So we're talking about rational expressions, and a rational expression is just like a fraction. Of course, we're going to have polynomials in those fractions. And then complex fractions are like when there's a fraction over a fraction. So a complex with just numbers, a complex fraction would be like 1/2 divided by 3/4. And this of course gets more complicated when you have variables in there, and these are polynomials, but the idea is still the same. If you have a number divided by a number, or a fraction divided by a fraction, you're going to multiply by the reciprocal. So this would be 1/2 times 4/3. And then you just get 4/6 or 2/3. All right, so I said what a rational expression was and a complex fraction, and I guess that's all our vocab. So we're first going to start, when you have numerator and denominator and you want to cancel to simplify, you want to cancel as many as you can, it has to be, absolutely has to be factors that are canceling. So in this case, I can cancel this whole factor, this y plus 7 and this y plus 7 from top to bottom. I would not be able to cancel just the 7 and just this 7 because that's not a factor. The factor has to be multiplied. So in this case, there's not much else I can do. So I have 3y over y squared minus 9. It says, under what conditions is the expression undefined? So this is the same thing as last time, but now we're not simplifying it. But we do have to figure out when, basically what the domain is. What can x, or in this case y, not be? So to do that, we just take all the factors in the denominator and set them equal to 0 because we don't want 0 in there. So this is one factor, the y plus 7. So we'll set that equal to 0. And then we will subtract 7 and we get y equals -7. So at -7, this expression is undefined. Now this y squared minus 9, that's a difference of squares. So I would actually want to go y minus 3 times y plus 3. And these two factors, if you remember the difference of squares, I know it's probably been a little while, but if you FOILed this, you would get this answer. So that's just that definition on how to factor a difference of squares. So then, of course, I set this y minus 3 equal to 0, and this y plus 3 equal to 0. And when I add 3 to this side, I get y equals 3. And when I subtract 3 here, I get y equals -3. So these are the conditions in which the expression is undefined, because -7, 3, and -3, any of those would make 0 be in the denominator, which would be undefined. All right, so this is, you guys go ahead and do it real quick. All you need to do is cancel those common factors. So you should have x over x squared minus 16, or b. Now decide what conditions it's undefined at. So to do that, you're going to have y plus 5 equal to 0. So we know -5 is one of the ones that can't be. And this would factor to x plus 4 and x minus 4. So when I set each of those equal to 0, I'll get a positive and a -4. So I have -5, +4, -4. Okay, this one looks a little different, but we're going to do it the same way. It says, for what value or values of p is this expression undefined. I'm going to change my color here. So we need to factor the denominator and set it equal to 0. Well, this is a quadratic. So again, when we factor, the first thing I want to do is look for GCF. Well, there's not a common factor among all three terms. So I look at it, I'm like, oh, it's quadratic. So I'm going to need to factor it into these two binomials. Now, I guess it's P, where you have two numbers that multiply to -15, but add to -2. So I would have a -5 and a +3. Okay, because -5 times 3 is -15, and -5 plus 3 is -2. So then I set each of those equal to 0, and when I solve each of those, I get a +5 and a -3. So those are the values where this expression is undefined. So it looks like B is my answer. Oops, that was a different problem. Okay, now you know the answer. But go ahead and do it. You need to factor these two numbers that multiply to 15 but add to 8. My p's are terrible. They're both going to be positive, and I'm going to say 3 and 5. Once I set each of those equal to 0, I get a -3 and a -5, like I had accidentally pressed too far. All right, so we're got to simplify this, but there's nothing that I can take out right away because there's not factors. This is subtracting two terms, so I need to get it in factor form. So if I look at my numerator and I take out the GCF is a to the 4th. What's left is b minus 2. On the denominator, it looks like I can take out a cubed. What's left is 2 minus b. Okay? And if this is confusing at all, just remember, if you distributed this back together, you would get this in the end. So we're just factoring it, we're breaking it down. Okay, well, the a's, we can cancel some of those. So a to the 4th divided by a to the 3rd is just a to the 1st. And then these factors look a lot alike, but they're not quite the same. Well, the interesting thing about this, if you have b minus 2 and 2 minus b, if you factored out a 2 minus b from b minus 2, you would end up with a -1. So when we're canceling this, you know, we are canceling it to a 1. This one we're actually canceling to a -1. This one we canceled to a 1, and this one we canceled to just an a. So our answer is going to be -1 times a, or -a, over 1 times 1, or just -a. Go ahead and try this one. You can pause it, and I will do it over here. And you should have got -x. Okay, so all this is saying is how to multiply fractions. In case you forgot, you just multiply the numerators across and the denominators across. And then if you're dividing factors, you are multiplying by the reciprocal. So you just flip and then you go ahead and you multiply. So here, like when we're multiplying fractions, we can cross cancel either before or after we've already multiplied them through. It is usually a lot easier to do it before. But if you're not comfortable with it, that's fine. You can multiply them all the way through and get 56 xy squared, you know, and then whatever 21 times 16 is, and keep going, and then simplify it. But I'll just start by cross canceling now. It does make for calculations to be easier. Okay, so I took 7 out of 21 and 8 out of 16, and I'm left with x y squared on top, and then 3 times 2, which is 6, and then x to the third and y to the third. But I'm not quite done. I just cross-canceled those numerals, so I can now continue to cancel out the variables. So I'm going to have 6 on bottom, so it's like 1/6, and I can take out this x on top, so I'm left with x squared on bottom. And then it looks like I am left with y to the first on the bottom, because when you take out y squared, you're just left with y to the first. So since there's just a 1 on top, this should be our answer. And you can look at the way they did it as well. They factored everything, and if that makes sense to you, you certainly can do it that way. Okay, a division one, but like I said, we can just multiply by the reciprocal. So I'll rewrite this, 10mk squared over 3c squared d times 6c squared d squared over 5m to the 5th. Okay, well, I'm just going to start by cross-canceling some of these numbers. So it looks like I'm left with a 4 on top. And then I have 1m here and 5m to the 5th down here. So then this is just going to be m to the 4th. So I'll write that. I have a k on top, k squared on top, but no other k's, so that stays. I'm done with that. I have a c squared on top and a c squared on bottom, which means they just cancel out to 1. And then I have a d squared on top and a d on bottom, so it's just one of those d's on top. Hoofda, that's super messy, but 4k squared d over m to the 4th. Okay, you can go ahead and do this, and I will do it while you're doing it. Looks like our answer is B. Here's another one. Again, if you want to pause it and go ahead and try it, go ahead. All right, it looks like I got D for an answer. It's not in the same order, but that's fine. Okay, so here we're just multiplying these through, and so I tend to skip this step, but if you want to see it, it's really just these factors being multiplied together. and then these factors being multiplied together. All right. So but I just usually skip putting them together because I can see it like this. So what you need to do is you need to first factor everything you can. So this up here, this numerator, I could factor this down because it's a difference of squares. So I could write it as 1 minus k and 1 plus k. And then this denominator here, I can factor that into k minus 3 and k minus 1. All right, so what I have is a bunch of factors. I have a k minus 3 here and a k minus 3 here, so I can cross-cancel those. I have a k plus 1 here and a 1 plus k there, which commutative property, same thing. And then I have a 1 minus k and a k minus 1. So remember, if I cancel or factor that out, this is just a negative 1. So what all of this does is boil down to a negative 1. All right, this is similar, but we're dividing, so we need to multiply by the reciprocal. So 2d plus 6 over d squared plus d minus 2 times d squared plus 3d plus 2 over d plus 3. Okay, so I'm going to factor everything I possibly can. So this numerator on the left side, I can write it take out a GCF, which is 2, so I'm left with 2 times d plus 3. The denominator, I'll have to factor it into these two binomials. So I'm going to have d plus 2 and d minus 1, because 2 times negative 1 is negative 2, and added, it's a positive 1. This lower right-hand expression is as factored as it can be, and then the upper right-handed one we can factor into d plus 2 and d plus 1. So now I can start canceling, and it looks like d plus 3 cancels, d plus 2 cancels. Now d plus 1 and d minus 1, there's nothing you can really do with that. So it looks like what's remaining is 2 and then d plus 1 over d minus 1. Some books want you to rewrite this then the top as 2d plus 2, so to put it back together, but I don't care. Either of those is correct for me. Okay, I'll let you do this. Looks like all those factors cancel out, and you should have got 1. And you can do this one as well. I'm just factoring as I'm rewriting it. I got A. Okay, last thing. I know this is long. Like I said, we're already on example 6. We're just going to simplify complex fractions. This is nothing new other than the way that you have to think about it. So usually people get scared of this, but I know you've been doing complex fractions for a long time. So we're going to just take that numerator and rewrite it. And then we're going to multiply it by the reciprocal of this denominator. So now the 2y minus 3x is on top. And the x cubed is on bottom. Okay. And then we're just going to go through the exact same steps that we did before. We're going to factor where we can factor. This isn't factorable. These two we can end up cross-canceling. And this isn't. Oh, I lied. This is factorable because we have a difference of squares. Because this is 3 squared, x squared, 2 squared, y squared. So this would just be 3x plus 2y and 3x minus 2y. And then this would cancel. This would just be an x on bottom. And then 2y minus 3x and 3x minus 2y, those will cancel with this being a -1. So it looks like I'm going to have a -1 on top, or the negative can be on top, on bottom, out in front, it doesn't matter. And then I'm going to have an x, and I'm going to have a 3x plus 2y as my answer. Okay, go ahead and try this one. I think I got C for my answer. Okay, your assignment is page 472, 14 through 38 evens, but you can skip number 24. So that's only 12 problems. You're just going to get good at factoring. Remember, if you can take out a GCF, do that first. That's your number one rule when factoring. And then if you have questions, you can talk to me on Wednesday, but I'd like you to try all of these instead of just having all of them as questions. So I will see you guys Wednesday.